This is a question in Testive's DSAT library, and this is a question that I wrote based on an existing practice test question from a College Board official test. So if we look at this question, it's short, the text is short. An isosceles right triangle has a perimeter of 74 plus 74 square root of 2 centimeters. What is the area of this triangle in square meters? So we know at the end of this, we want an area in square meters. And you might initially, or hopefully you initially see that this is in meters and this is in centimeters, which means at least part of this is going to be a unit conversion. And additionally, we're told that it's an isosceles right triangle. So if we were to draw an isosceles right triangle, we're going to pretend that's drawn accurately. We would know that the sides are x, x, x root 2. And if that is not something that came to mind immediately, we just have to go back to the definition, right? Isosceles meaning two sides are the same, a right triangle. And because if two sides are equal, the opposite angles have to be equal, right? So if I were to label this ABC with the hypotenuse being AC, I know my AB and BC are the legs, X and X, and that means angle A has to equal angle C. And they can't be the right triangle because they can't be the right angle because if A equals 90 and C equals 90, well, that's already 180, and we know triangles have 180 degrees. It just doesn't work. So if you find isosceles right triangle, this is the side ratio. Now, if you don't have that memorized, that's okay. As long as you know that it's isosceles and right, you just have to remember that you are given that on the reference sheet. So this is a screenshot of the reference sheet in Blue Book. If you're taking it in the app, you would click up here. When you're looking at the question, it'll say reference sheet, it'll pop up, and you can see we have exactly what we want right here. Special right triangles, 30, 60, 90, which we're not concerned about for this question, but a 45, 45, 90, X, X, or in this case, it says S, 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 S root 2, and that's our isosceles right triangle. So that is there for you if you need it. When we come back here, we know we have an isosceles right triangle. We know it's perimeter being the distance around. So if I were to sketch it out, and again, I'll write my X, X, X root 2. Initially, our first test will probably be, oh, that's 74 root 2. It's probably the hypotenuse. But you might also see immediately that can't be possible because then if that's 74 root 2, X is 74, this is 74. We have 2 times 74. This is too big, so it doesn't work out. And so again, if I draw a different right triangle down here, that means that probably my 74 is the hypotenuse because there are 3 sides. So that means that either one side is 74 root 2 or the sum of the other sides is 74 root 2. And then this is 1. No matter how you split this, one of these is the sum of 2 sides and one of them is hypotenuse. Now, if that's x root 2, this is x. I can solve 74 equals x root 2. That tells me 74 over root 2 equals x. And you can actually put this into Desmos, right? You could type this in, it'll give you a decimal. And then you could use that to estimate, but I'm going to actually keep it so it looks clean in my format, x root 2. And I know that if I take 74 root 2, I'm going to come over here to the left, 74 over the square root of 2, I multiply 1 by 1 in this form of square root of 2 over square root of 2. So I change how it looks, but not the value. This becomes 74 root 2 over 2, which is 37 square root of 2. So those are going to be the lengths of my sides. So if that's 37 root 2, this is 37 root 2, you can see that 74 plus 37 root 2 plus 37 square root of 2 equals this. So I now have the dimensions of my triangle. I'm going to clear it and write just the triangle again on its own. Remember, this is all in centimeters. So I know it's 74, 37 root 2, 37 root 2, and I want the area. And the area of a triangle, also given to you on that reference sheet, if you happen to forget it, equals 1/2 base times height. And in this case, my base and height are the same because I have isosceles right triangle. So I know it's going to be 37 times the square root of 2 times 37 times the square root of 2. All over 2. And if I simplify the numerator, that's 37 squared, and then the square root of 2 times square root of 2 is just 2. So that's times 2 over 2. My 2's cancel out. It's 37 squared, which you can put in your calculator and get us here. But you might say, that's not the answer, right? Clearly, this is the answer. It's already highlighted for us. Why? Because this is in centimeters squared. This is in centimeters squared. And we, of course, want it in meters squared. Now, if you pay attention to that and you see that you're in centimeters squared, you want meters squared, and you know that your metric system is base 10, which just means if you're converting between any two, meters, centimeters, kilometers, whatever it is, the only thing you're doing is moving the decimal point, right? You add or subtract zeros, you move the decimal point. So it can't be these two. They have the different digits. You can get here without doing any additional work. But if we want to get there, you want to think about how you do your linear conversion. So if you want centimeters to meters, right, there's 100 centimeters in 1 meter, which means if I want to go from 1 centimeter to how many meters, well, I'm just going to divide everything by 100. So similarly, if I want centimeters squared to meters squared, instead of divided by 100, I'm going to divide by 100 squared, which is 10,000, which means I'm going to move the decimal point 4 units to the left. And you can see here, 1, 2, 3, 4 is here. So that is why it is B.